Section 2.4. Section 2.4 is talking about more things about slope than we talked about last time we met. The objectives for this section are to find slopes and equations of parallel and perpendicular lines, to interpret slope as a rate of change, and to find a function's average rate of change. Okay, you already know how to do all of this, so this is just a review lesson. Okay, finding slopes of parallel and perpendicular lines, first of all. Okay, if I tell you one particular line has a slope of 1/2, and I want the equation of the parallel line with that also has, the equation for the parallel line, I want you to tell me the slope of the new equation, because parallel lines have same slope. Okay, if I tell you the slope is 1/2, I want to know the perpendicular slope, the slope of the line that's perpendicular to this. What kind of slope is it going to have? -2/1. And how do you know that? Opposite and reciprocal. Okay, so m is going to be equal to -2. Okay, so something you may not have thought about before, if we're talking about perpendicular lines, not parallel lines, okay, not parallel lines, because parallel lines have the same slope. Okay, there's a couple rules real quick about parallel lines I just want you to think about. If two non-vertical lines are parallel, then they have the same slope, which to me is a little odd, because if they are vertical lines, you're going to be able to tell if they're parallel because they're both vertical. And the reason that it says non-vertical lines is because vertical lines don't have a slope. Those are undefined. That's an undefined slope, is why it's saying two non-vertical lines. Okay, but pretty much we just say two lines are parallel and they have the same slope. Okay, if two distinct non-vertical lines have the same slope, then they're parallel. So it goes both ways. Okay, if they're parallel, then they have the same slope. If they have the same slope, then they're parallel. All right. Two distinct vertical lines, both with undefined slopes, are parallel. So if they're vertical, then they're still going to have the same, well, they're still going to be parallel because they're vertical lines. They don't have a slope to compare because they're undefined, but they're still going to be parallel. Okay. Perpendicular is something you may not have thought before. What is the product of the slopes of perpendicular lines? What do I mean by product? Multiply. So what's 1/2 times -2? That would be -2/2, which equals -1. If m is 3/4, a perpendicular line would be -4/3, right? The product of 3/4 and -4/3 is what? -1. So what is the product of two perpendicular lines? -1. Okay. So what does that mean if I know the products are -1 of two particular slopes? Does that automatically mean then the lines are perpendicular? Yeah, it works the same way as parallel lines. Remember I told you parallel lines, if they have the same slope, then they're parallel. But also, if they're parallel, then they have the same slope. Works the same way here. If their slopes are perpendicular, then the products are -1. If the products are -1, then you can say that the lines are perpendicular. Does that make sense? Okay, so that's something you've known all along. You may not have thought about the fact that the product of two perpendicular lines are -1. Okay. What about a horizontal line and a vertical line though? Aren't those going to be perpendicular? Are their products going to be -1? Well, vertical line doesn't have a slope. So obviously their product can't be -1, because you can't have a slope on an undefined, a slope of a vertical line is undefined, so you don't have a slope. But you are also wise enough to know that a vertical line and a horizontal line are going to be perpendicular. Does that make sense? Okay. I'm not going to go through finding equations of parallel and perpendicular lines because that's basically what we talked about yesterday. If you know a point and a slope and it tells you it passes through the same point but it's parallel to this, well, that's silly because it can't pass through the same point and be parallel because it's the same line. So in that situation, they would give you a separate point and say it's parallel to this line but passes through this other point. So you would just know to use the same slope to find the new equation. Okay. Same way here, it might even tell you passes through the same point but it's perpendicular. It can pass through the same point and still be perpendicular, right? It happens probably to be the point that they intersect at. But they'll give you a point and a slope and say it's perpendicular to this slope and pass through this point. You can find an equation like that. That's not a problem. Okay? Interpreting slope as a rate of change. Have you heard ever before in your life that slope can be also talked about as a rate of change? Yeah, in fact, it came out of my mouth, right, in Algebra 2. Slope and rate of change. And sometimes even on the STAR test, those things are interchangeable. It'll say, find the rate of change of this line, and it's asking for the slope. Okay? So slope is a rate of change. Typically, though, you talk about slope being a rate of change in a word problem. Okay? It's not going to just say, y equals 2x plus 4. What's the rate of change? Well, it doesn't really make sense in that situation. Usually it's talking about something that's literally changing, like a word problem. Okay, but once again, all you're doing is you're finding the slope based on the points that you're given in the word problem. Okay, last thing is find a function's average rate of change. Well, not every function is linear. Okay, not every function is linear, and so in a function like this blue function right here, I can't really find a rate of change at our level. Okay, there's tons of stuff you can do in calculus to find rate of change here. Okay, but if we're given 2 points and we're asked to find the rate of change between these 2 points, it's obviously not going to be a line because it's clearly a curve right here. But we can take the 2 points of given information and we can find an average rate of change. So between these 2 points, if it was a line, what would the equation of the slope be? Excuse me, what would the slope be? What would be the average rate of change between those 2 points? And if you look at this little formula that they give, is that anything new? No. You know that if we're talking about functions, if we're talking about equations, just y2 minus y1 over x2 minus x1, right? But if we're talking about functions, isn't f of x sub 2 the same as y sub 2? It is, right? So this is not any sort of new formula that you're given. This is something, it's just written in function notation. Okay? If this is a point and this is a point, but you've seen stuff like that before. So even finding a function's average rate of change is not anything, it's not anything different than we've done. Okay? For example, if it's saying find the average rate of change of a parabola, of a quadratic, from x sub 1 is 0 and x sub 2 is 1. Well, what is the function when f is 1, or when x is 1? Well, what's 1 squared? You go back to the equation they give you. What's 1 squared? 1. So even though they didn't give me the y values or the f of x values, isn't that something, given the formula that we have, that we can find fairly easily by substituting into the equation? Okay, so f of x sub 2 and f of x sub 1 is something we have to find by substituting these values into the given formula. And then x sub 2 and x sub 1, obviously, we're given right here. 1 minus 0 is 0. 1 squared minus 0 squared is 1. So 1 divided by 1 is 1 in that particular example. Okay, if we're finding average rate of change for x squared from 1 to 2, well, you know that's part of the curve, part of the parabola right down here. Okay, so it's not going to be a straight line from there to there, but we're finding an average rate of change. Okay, we're pretending that it's a line and finding the slope of the line right there. Again, that's something you do all the time in calculus, but we're not there. Okay, so we're finding what's called an average rate of change. We take the function that we're given, plug in 1 to find f1, f of 1, x sub 1, and plug in 2 to find f of x sub 2. So 2 squared is 4, 1 squared is 1, so 4 minus 1 is 3. 2 minus 1, plug in the x's, 2 minus 1 is 1, so 3 divided by 1 is 3. Does that make sense for finding average rate of change? You don't just take the numbers you're given. You actually have to evaluate these two numbers at the function to find your f of x sub 1 and f of x sub 2. Got it? So those are our three objectives today. Finding the slope in equations of parallel and perpendicular lines, interpreting slope as a rate of change, and finding a function's average rate of change. Any questions?